Hi there. In this video, I want to do a couple things. The first is connecting the types of simulated distributions that we've looked at, okay? They all look very similar in the end. They look like a normal shape, but I want to just reiterate the difference, go over the difference between the three, okay? So the first one we looked at is called a sampling distribution. And we were actually studying sampling distributions when we did this. Okay, and so what it is, it's a distribution of sample statistics from random samples. So we calculate repeated random samples from a population, calculate a statistic, and we graph that on a dot plot. Okay, so a key word here is it's from a population. We're taking random samples from a population, we're calculating a statistic, a mean or a proportion, and then we are graphing it on our graph. So it looks like a dot plot or histogram. Now it's centered at the true value of the population parameter. That's where the middle is going to be, the center. Usually the mean, because it's symmetric, right? Okay, so the thing, remember about this was, usually we don't know the true value of the population parameter. That's why we need statistics. But here we're pretending we do know the parameter so that we can understand the behavior of random samples, okay? So remember, that's why we were doing that one. I want to contrast that with a bootstrap distribution, okay? This is when we don't know the population parameter. So a bootstrap distribution, we used this when we were studying confidence intervals, right, and making confidence intervals. So I'm going to write that here. Should have left myself more space. Okay, so we studied that when we were doing confidence intervals. And this is a distribution of sample statistics from resamples of an original sample. Okay, so we took one sample, which is what we do in real life. We take one sample and then that's all the information we have. So we resampled from that one sample with replacement, pretending that our population is many different copies of that sample, okay? And that is to simulate this sampling distribution, okay? But we don't know the true value, so, and we're going from the sample, so it will be centered at the original sample statistic. Okay, so whatever our mean or proportion was, it will be sampled right there. It will be centered right there. And then the third thing we've done more recently is a randomization distribution. Okay, and we used this for hypothesis testing. Okay, so this is a distribution of sample statistics, so that thing is the same for all of these. The distribution of sample statistics. But this one is assuming the null hypothesis is true. Okay, and it'll be centered at the value of the null parameter. And we've seen that, right? Like when we're testing the difference between two things, then the null is that they're the same and we have 0 in the center. Or whatever our null value is, that is in the center. Okay, so I hope that just gives you a little refresh and recap and just comparing and contrasting the different types of simulations we've been doing. Okay, there's one more thing I want to talk about in this video, and that is the problem with p-values. Okay, I don't know if you've heard about this before, but it's controversial. P-value methods have been criticized and even banned from some journals, okay? So some of the reasons for this are the significance level of 0.05 seems arbitrary to some people, and it also is this binary, did you meet the 0.05 or not meet the 0.05? It makes this binary decision, and it's a high stakes decision if you're trying to get your results published in a study, right? So what if it comes out to 0.0501, right, versus 0.0499? Is there really a difference between those two? Not really. So there's also many ways to influence a study or trying to get your result under the significance level, and that's called p-hacking. If you're trying to influence, that's called p-hacking. Some people have referred it to that. So it's possible, hopefully people wouldn't do that, but it's possible, right, to make a minor tweak and then get under that result, okay? Another consideration or concern about it is the p-value measures evidence against the null, right? We're either rejecting or failing to reject the null. We don't accept anything. We're either rejecting the null or failing to reject the null because we set our whole test up under the idea that the null is true. So we're really only measuring evidence against the null. We're not measuring evidence for the alternative. It's just against the null. So we're saying if it's against the null, it's for the alternative, but it's really just measuring evidence against the null. It doesn't have a lot to do with the alternative. What if the alternative was something else? So those are some of the issues with p-values, and it's good to be aware of, right? It's also another issue with it is they're really misunderstood. So if you watch outside videos, be careful because they might be explaining it wrong. It's really common. So one thing that people are suggesting is instead of a binary, why not have more of a scale? You know, instead of just the reject or fail to reject, talk about the strength of the evidence. Okay, so I'm trying to add this more into my conclusions as well. So talk about the strength of evidence. Is it weak evidence? Is it moderate evidence? Is it strong evidence? Is it very strong evidence? So let's look at a few different ranges. Let's say your p-value is big. It's greater than 0.10. We could say there's not much evidence against the null. The null is plausible, right? It could happen 10% of the time, so it's fairly likely. Then maybe between 0.05 and 0.10, that's moderate evidence against the null, okay? Up till now, we've been failing to reject the null in these two cases, right? Then here we're getting into where we have rejected the null. If we're under 0.05, or equal to or under 0.05, down to 0.01, we could say that's strong evidence against the null. And if it's less than 0.01, that's very strong evidence against the null. And we have seen that in some of our examples. So I would consider just writing more about the strength of evidence in our conclusions. We're still going to make our decision just for our homework problems based on the significance level, but this is just something really important to think about in real life studies. There have been many letters and articles written about these problems, and so I've linked a few in D2L if you want to read more about that. Okay, great. I'll see you in the next video.